Jai Gurudev, all my dear students. Today I'll discuss one of the chapters of class 8 mathematics, which is exponents and the powers. As you know, when we multiply a certain number multiple number of times, we can express that as its power. For example, if you multiply 5 3 times, we get 5 cube. Here what we find is that 5 represents base and 3 represents its power, which is also called as exponents. Few examples would be 2 multiplied by itself 5 times would give 2 to the power of 5. Here 2 is called the base, 5 is called its power or exponent. Now, there are certain basic formulas which we call as laws of exponents. First law says that if you take one number called as a raised to the power m, and then if you take another same number, that is a and raised to the power n, it always gives the result equal to that number to the power m plus n. To be more clear, let us see an example. If you take a as 2, m as 3, n as 4, what we get here is that a to the power m into a to the power n is equal to a to the power m plus n. Now, if we divide that and if you want to verify the formula, that how it is being derived, we can do this using a simple example. Since I have taken the base as 2, that is a value 2 means here the base is 2, so I can write here 2, m value, one of the exponent or power we have taken as 3, then once again base 2, a value 2, then another power or exponent we have taken as 4. Similarly, here also we'll write base 2 and that powers, I'll add it up, that is 3 plus 4. 2 to the power 3 plus 4. Now 3 plus 4 gives 7. That means this 7, 2 to the power 7. Here I'll be multiplying 2 7 times. 1, 2, 3, 4, 5, 6 and 7. When I multiply this 7 times, I get result as 128. Now come back to the left hand side of this law. 2 cube is 8. 2 to the power 4 is 16. If you multiply 8 and 16 together, you get result as 128. Therefore we find that a to the power m into a to the power n is equal to a to the power m plus n, and that is how we verify this formula. Hence verified. This is the first law of exponent, that is a to the power m into a to the power n is equal to a to the power m plus n. Second law of exponent says that if you take a to the power m as one of the components which is divided by a to the power n, our formula is a to the power m minus n, where a is acting as a base, m as the exponent of the power. A is acting as a base, n as the exponent of the power. Here a as the base, m minus n acting as the subtraction of the power. Now if I have to verify this formula as well, let us take the previous example only, where we have considered that a is equal to let's say 2, m equal to 3, n equal to let's say 4. Simple example. I will see. Now if I place the value a I have taken as 2, m value I have taken as 3. I'll divide it. A I have taken as 2, n value I have taken as 4. So when I have taken this 2 cube, now 2 cube value will be 8, 2 to the power 4 value will be 16. So 2 cube I'll write as 8, 2 to the power 4 I'll write it as 16. So 8 divided by 16 value is half for the left hand side part. Now a to the power m minus n. A value already we have assumed it is 2, m we have taken already 3, and we have taken 4. So a value I'll write here 2, m value I'll write here 3, n value I'll write here 4. So 2 to the power 3 minus 4. Now 3 minus 4 is minus 1. So 2 to the power minus 1. So 2 to the power minus 1 is actually 1 by 2. That we'll see how. Here, since a to the power minus n is equal to 1 by a to the power n, that we'll see. Okay, so it's 1 by 2. Now what we find is that a to the power m divided by a to the power n. A to the power m divided by a to the power n is equal to a to the power m minus n. And this is how, with a simple example, we can verify this formula. A to the power m divided by a to the power n value is 1 by 2. This 1 by 2. Similarly, a to the power m minus n, which is the right hand side of this formula, is also half, which implies that a to the power m divided a to the power n is equal to a to the power m minus n. So second formula is also verified this way. Third formula. Anything to the power 0 is 1. Now how to prove this? What we will do, we'll take here left hand side. Left hand side is a to the power 0. So let's take the left hand side and we'll try to prove the RHS. So a to the power 0. This a to the power 0 can be written as a to the power 1 into a to the power minus 1. Now why we can write? Since bases are same, powers will be added. So plus 1 and minus 1, when I'll add, my expression will be a to the power 0, which will remain. a to the power 0. So this a to the power 0 is equivalent to a to the power 1 into a to the power minus 1. This goes by the formula of a to the power m into a to the power n, which is equal to a to the power m plus n. So you can see, if I take a to the power 1 and then a to the power minus 1, so next step would be a to the power 1 plus minus 1, which is 1 minus 1, which is 0, a to the power 0. So my left hand side it remains same, so I can write this expression. Now a to the power 1 means a, and this become a to the power minus 1. Now a to the power minus 1 formula goes, since a to the power minus n, since a to the power minus n is equal to 1 by, since a to the power minus n is equal to 1 by a to the power n. So instead of this a to the power minus 1, I can write 1 by a. Now here nothing is there, that means it's 1, although we do not write, but still. Then this numerator, this denominator can cancel out each other, which will make it 1. So that is how we can verify that a to the power 0 or anything to the power 0 is 1. Verified, I'll write rather, hence verified. This is the third law of exponent formula. So a to the power 0 equal to 1. This is the verification process. One more time. Left hand side we have taken a to the power 0. Second step, a to the power 1 into a to the power minus 1. Now why you can write, because when we will evaluate this step, a to the power 1 into a to the power minus 1, this will give a to the power 0 only, because by the first laws of exponent which you have seen, when bases are same, powers will be added, and when we add 1 with minus 1, our result is 0, so my original expression remains same. So therefore this expression can be written, instead of a to the power 0, we can write a to the power 1 into a to the power minus 1. Now a to the power 1 means only a to the power minus 1 means the formula is a to the power minus n, which is equal to 1 by a to the power n. So 1 by a. Numerator and denominator get cancelled, equal to 1 is the required answer. This is the third law. Fourth law of exponents says that a to the power minus m is equal to 1 by a to the power m. Okay. Now how to verify this formula also? That is, if the power or the exponent is negative, then it actually get reciprocal of it. That is, a to the power minus m is equal to 1 by a to the power m. Now how to prove this formula? Just now we have come across that anything to the power 0 is 1. Okay. The third formula that we have seen just now, we know anything to the power 0 is equal to 1. Instead of a to the power 0, what can be written? Since it is a to the power 0, so I can write a to the power minus m into a to the power plus m equal to 1. Because if I write here a to the power minus m into a to the power plus m, bases are same. So since bases are same, powers can be added. So when I'll add minus m with plus m, my expression will become a to the power 0. Therefore left hand side remains same. I am not violating the statement. So instead of a to the power 0, I can write a to the power minus m into a to the power m, and right hand side remains same, equal to 1. This is called left hand side, this is called right hand side. Now a to the power minus m, here it is multiplication symbol. So we know when the multiplication is transferred, or the number or the value that is related with multiplication, when you transfer it with the right hand side of equal to, it converted into division. Multiplication converts into division. Therefore a to the power minus m is equal to 1 by a to the power m. So that is how the fourth formula is also verified. One more time. Fourth formula says a to the power minus m equal to 1 by a to the power m. That is, if the power of the exponent is negative, then it gets reciprocal. Now how to verify it or how to prove it? We know just now, we have seen from the third laws of exponent that anything to the power 0, any number to the power 0 is actually equal to 1. So we have written a to the power 0 equal to 1. Now instead of a to the power 0, I can write a to the power minus m into a to the power plus m. Now when we write this expression, this actually comes from this formula, a to the power m into a to the power n. Its formula is a to the power m plus n. So here if I convert this into the first laws of exponent formula, we'll get a to the power minus m into a to the power m equal to a to the power minus m plus m. So a to the power minus m and a to the power plus m will cancel each other, and result will be a to the power 0, which is my left hand side. Therefore I am not violating the left hand side. Therefore a to the power minus m into a to the power m equal to 1 can be written instead of a to the power 0. Now we know that since the second number is related to the first number with multiplication symbol, and if I transfer multiplication symbol to the right hand side of equal to, that becomes division. So therefore a to the power minus m remains on the left hand side, and I convert one of the numbers to the right hand side with a sign transfer, which makes multiplication to division. Therefore a to the power minus m equal to 1 by a to the power m. That verifies the fourth formula as well. Fifth formula says a to the power m equal to a to the power n, which actually implies m equal to n. Now here it means if you have got any number where base is same, for example 5 to the power 3, 5 to the power, let's say any number, the number remains as n, it implies that n equal to 3. Logically how it follows, since both the bases are same, so it is only possible that numbers will be equal if their exponents or the powers are equal. Therefore it implies that if a to the power m or any base which are equal, then their exponent must also have to be equal. So the fifth law says if a to the power m is equal to a to the power n, only then their exponential portion, that is exponential parts, must be equal. That is the fifth law. Sixth one is a very simple one, all of you know, I guess. A to the power a into b to the power m is written as a to the power m into b to the power n. Simple example, if two numbers multiplied and is whole to the power some exponent, it is individually being distributed. For example 2 into 3 to the power 4. So what we do, 2 into 3 to the power 4. So individually that exponent, individually here the exponent will be distributed to both 3 and 4. That is 2 to the power 4 into 3 to the power 4. That is the sixth law of exponent. Seventh law, a to the power m and n is equal to a to the power m into n. If you have got any base with one exponent and then that number is also governed by second exponent, then simply we multiply both the exponents. Therefore a to the power m whole thing bracket to the power n is equal to a to the power m into n. Example 4 to the power 5 whole thing bracket 7 is actually equal to 4 to the power 5 into 7 equal to 4 to the power 35 is the required answer. That is law number 7. divided by b is governed by minus or inverse of its power, that is the negative power, then it always reciprocates the number. That is, if it is a by b, it becomes b by a to the power positive m. If a number is governed by negative exponent or the negative power, then the number itself can reciprocate with the positive exponent. It follows from the fourth law, that is, we have seen a to the power minus m is equal to 1 by a to the power m. That is the fourth law, that we have seen a to the power minus m is equal to 1 by a to the power m. So here what we have seen, if it is negative of the power, then the value get inverse. Similarly in this case, here is a by b to the power minus m, a by b to the power minus m. So if I take individually numerator and denominator, what I find, a to the power minus m. A to the power minus m can be written as 1 by a to the power m. Then similarly, that's b. b can be written as divided. b to the power minus m can be written as 1 by b to the power m. So if I convert both of them, it becomes b to the power m by a to the power n, which implies b by a whole thing to the power m. The law and the last laws of exponent follows from fourth law, that is, individually if I take those numbers, let's say this a, if I take individually a to the power minus m, so my a to the power minus m value is a to the power minus m is equal to 1 by a to the power m. So what we can do, individually a to the power m can be written as 1 by a to the power m. So accordingly we have written 1 by a to the power m. Then this division, so we have given here the main division line. With this division we have got b to the power minus m as well. So b to the power minus m can be written as 1 by b to the power m with the main divided line. So 1 by b to the power m, and then it goes to the numerator as usual, and then a to the power m comes to the denominator, right? So it becomes b to the power m divided by a to the power m, which can be more precisely written as b by a whole thing to the power m. So that concludes actually the exponent and the power, all the laws that you have got in your syllabus, the 8 laws. So here we can write hence verified. Okay, LHS equal to RHS verified. These are the 8 laws of exponent. On to some exercise. First exercise is exercise 4.1. First question is evaluate the value. Evaluate. Number 1 is 6 by 11 is whole square. So since it is whole square, that is a by b to the power m, then individually I'll square it. So 6 by 11, this is whole square. So individually I'll write 6 square by 11 square. So 6 square can be written as 6 into 6. 11 square can be written as 11 into 11. Now 6 square we know is 36. 11 square we know it's 121. So that's the final answer. So evaluate first question is 6 by 11 whole square. Answer is 36 by 121. question is minus 2 by 9 whole to the power 5. Now one thing we have to get clear, that if the power is odd number, negative sign remains. If the power is even, negative sign changes into positive. Now since here 5 is an odd number, therefore negative will remain. So this can be written as minus 2 into minus 2 5 times. 2 into minus 2 into minus 2, that is 1, 2, 3, 4 and 5 times. Similarly 9 can be written in 5 times. 1, 2, 3, 4 and 5. So if we multiply 2 5 times and this, the result is minus 32 by 59049. That is the second question. Third one is 5 by 6 whole cube to the power 2. 5 by 6 whole cube to the power 2. Now here what we can do, since it becomes the formula of a to the power m to the power n. So I can write a to the power mn, since a to the power m into n is equal to a to the power m into n. Therefore I'll convert it into that formula. So it will become 5 by 6 to the power 3 into 2, which is 5 by 6 to the power 6. 3 into 2, 6. So I'm just simply multiplying instead of evaluating the inner value. So it gives 5. I'll be writing it 6 times. 1, 2, 3, 4, 1, 2, 3, 4, 5 and a 6. Similarly 6, I'll be writing it 6 times. 1, 2, 3, 4, 5, 2, 3, 4, 5 and 6. So if I go on multiplying all these values, okay, so I'll be getting answer as 15625 divided by 46656. All these calculations all of you can cross-examine. Okay, so this is the third question, that is question number C. Now question number D is 1 by 2 whole cube into 1 by 2 to the power 4. Now here individually you can evaluate the values, or else the simpler method would be, since you can see here also 1 by 2, that is half, here is also 1 by 2 half, that means my base is same here, base here is half. So what I can do, if base is same, powers can be added or exponent can be added, therefore we'll use the first formula, that is 1 by 2 to the power 3 plus 4. And the reasoning part would be, since a to the power m into a to the power n is equal to a to the power m plus n. Okay, so that can be written as half to the power 3 plus 4 means it will be written as 7. So 1 to the power 7 means is 1 only, so no point writing, and it is 2 to the power 7. So individually, so 1 by 2 to the power 7, the value will be 128. Fifth question, that is question number E. 2 by 5 whole cube divided by 2 by 5 whole to the power 4. Now here also you can individually evaluate the expression, or else it would be better that you go by the formula, laws of exponents, since it will hold that formula. Now here you see 2 by 5, here also 2 by 5, that means my base is same. So since bases are same and with a division operator, therefore what you can do, we can use the second formula, that is 2 by 5 to the power 3 minus 4, and the reasoning part would be, since a to the power m divided by a to the power n is equal to a to the power m minus n, so it gives 2 to the power 5, 3 minus 4 is minus 1. Now since it is minus 1, the exponent of the power is negative, so what we do, we convert that into the next formula, that is a to the power minus n equal to a to the power n. So 1 divided by 2 by 5, that is a to the power n, here n is positive, and reasoning part would be, since a to the power minus n equal to 1 by a to the power n, so it gives, since this is the main divider, therefore 5 will come to the numerator. Okay, since it is 1, that means it is 2 by 5 only, therefore the final answer is 5 by 2. That is the question number E. That is the fifth question. Question number F, G, H, I, J. There are 4-5 questions, so this will be your homework. All of you make one separate notebook for maths, and whatever classes are being taken now won't be repeated after the reopening of the school. So you should keep that in mind. So few questions I'm giving, that will be your homework. So these are the 5 questions that all of you solve at home. Thank you. Jai Gurudev.